Perfect. So let's go. Good morning and welcome to this SmartEnergy 6-pack series on smart grids. This is an online investor training and B2B on game-changing energy trends. My name is Bastien, and with Ingrid, we will be your hosts today. This event is co-organized by the two main French clusters. On the energy side, we have Tenerrdis, and on the digital side, we have Minalogic. Let's start with some basic rules. So this is a recorded session. So if you have any objection, please let us know. The mics are off. So for any further questions, please write it down on the chat. So this is the last webinar of a series of 6. We started on the 4th of March and today, the 8th of April. This is the last session. This has been pretty intense, but we are really grateful for your participation and loyalty. So a small retrospective on the 6 weeks. We have, during 5 sessions, 25 speakers, 36 with today's sessions, from private, public, NGOs, and business organizations. We had 238 participants from 16 different countries. As you can see, you have the list of the European one, but we have also the pleasure to host outside participants from outside countries, from UK, Lebanon, USA, Canada, Togo, and India. Our participants were mostly companies, as you can see, but we have also from public organizations, from the European Commission, and also regional organization, business services organization, accelerators, and so on. Also research centers, university, and of course, our fellow clusters. Small retrospective on the participants that we had. We have leading key actors from investment organizations, private organizations, public ones, research centers, university, schools, association and collaboration between research centers and companies. Some projects have been presented from large companies as Schneider Electric, but also smaller ones as Probayes or pioneer entrepreneurs from both energy side and digital side. All this information, all those innovation networks and contacts will be available to you. We will be sending you a follow-up email, but it will be also available on our YouTube channels, website, and of course on demands if you ask us, Tenerrdis or Minalogic. Please bear in mind that we also have this information in 2 other programs that we have from our colleagues on hydrogen technologies and energy communities. So if you're interested about it, don't hesitate. You can send us an email or you can contact them directly. And now I will give the mic to Ingrid. Good morning, Ingrid.
Thank you, Bastien. Good morning, everyone. So I'm Ingrid from Tenerrdis Energy Cluster, and we are very happy to host you for this webinar session. So now, I want to talk to you about a platform that has been set up by the European Commission that is called the European Cluster Collaboration Platform. And it's possible for all of you to register on this platform as visiting organizations and to benefit from this cluster exchange program to match with some entities and organize some activities together. So there is an automatic tool that allows you to identify which some partners to match with based on some criteria such as the sector, the country, the organization type. And originally, this was meant to be used for physical visits. So you also have the length of stay indication. Of course, right now, at the moment, it's not very useful as we all went to digital activities. a look at today's program. So we have decided for today to give the floor to some regional SMEs who are very active in both the energy and the digital sector. And each of our clusters, Minalogic and Tenerrdis, we have selected 5 or 6 of our members to pitch in front of you. And we believe this format will be quite lively, because these will be short presentations and will allow you to get a wide variety of presentation on many different topics. Then, so this will take about 2 hours or maybe a bit less. Then we will have some presentations by our partners in this European program. So the Flanders Cluster called Flux 50, which is a cluster on energy based in Belgium. And they will present to us briefly their cluster and what they are doing with regards to smart grids. And then we will give the floor to another Belgium cluster, but based on the French side of Belgium, French speaking. And this is Tweed, a partner of Tenerrdis as well in some other European projects. And Frederick Lux will also present to us his cluster and his activities in the smart grid sector. Then we will have a short break if you need one, or you can directly go to the matchmaking platform. We remind you that this tool is available to you for free. You need to register. It's a different registration process than registering for this webinar. Sorry for the complexity, but we could not avoid it. So you have all the links here. It will be reminded in the chat as well. And you can set individual 15 minutes meeting with people who are registered on this platform. And then that would be the end of our session. So thank you again for being with us today. So this is the link that we will use later on for the matchmaking session. And if you have some time to make some appointment or registration, you can do it also in a background. So now I will give the floor to Claire Marie, who is a business developer for ODT. So ODT is a startup member of Tenerrdis cluster, and who is very active in solutions for low voltage networks based on smart meters. So Claire, the floor is yours. Can you listen to us?
Yeah, thank you, Ingrid. Thanks for the introduction.
Thank you.
Hello, everyone. I'm glad to be here today in Tenerrdis and Minalogic webinar in order to talk about smart grid and to present our company, ODT. As Ingrid said, I am a business developer at ODT, and I will start by explaining to you what we are. So ODT, we are a French startup that has been created in 2017. And now we are 13 persons, and we have been created by 6 co-founders that came from Schneider Electric and academic lab focusing on electrical engineering. So the strength of ODT team is really to mix those 2 competencies. So the competencies from electrical engineers that has been acquired from several years by the co-founders, and also competencies that data scientists, that our team of data scientists have on data analytics. And what we do in ODT is, what we do in ODT is offer a software that helps DSO, so distribution network operator, in the decision-making process for planification and control of the low voltage network. So how we do that? The first step, it's a core of our solution, is to first digitize the low voltage network. And why we digitize the low voltage network? We do it because we know that the characteristic of the low voltage network, so for example, the section of cable, the topology of the low voltage network, all of those characteristics are often unknown or wrongly registered in the DSO tool, and consequently, the simulations that are based on those characteristics are often wrong or not efficient. That is why in ODT we developed an innovative algorithm that retrieve the low voltage network, the tree of the low voltage network, using only meters data in the field. This is the only information that we use with our algorithm to build and to retrieve the low voltage network. And this is what we call digitization or creation of the digital twin of the network. And it reproduces the network exact behavior, and it gives the right basis, the correct basis to run simulation and to plan and to have a good planification on the low voltage network. So with this digital twin, we have several services that help DSOs for planification and control. The first services that we offer is the topology. So it's retrieving, like I said, first the tree of the network, and after we give the right association between the meters to the transformer. But also we go further and we find the right association between the meters and the feeders and the phase in the low voltage network. This is the first use case that we have that is called topology. The second one is network analysis. So we analyze the secondary substation and the voltage plan, meaning we can say if the transformer, how much the transformer is loaded. Also, we can say if the substation is balanced or unbalanced. And we can also check the voltage plan and to see if the quality of supply is good. The third use case is impact prediction. So this is first we create a map of the real capacity of the network to host any new loads. For example, new production or new consumption means, like solar panel, like charging for electrical vehicle, for example. So first we build this capacity map of the real network as it is. And after we can run simulation or in order to see the impact of adding these new loads on the low voltage network. The fourth use case is non-technical losses. So it's to find the missing energy in the low voltage network, to quantify and to locate this missing energy. It's really useful for DSO in the asset management process in order to know the real load at the substation level, for example. So the fourth use cases that I just presented are more oriented for planification. And the last one that is called real-time state estimation is more a supervision and control tool for DSOs, because we know that smart meters from low voltage network don't communicate in real time. It communicates often the day after. So when the DSO, for example, needs to have in real time the state of the network, the load of the substation or the voltage plan, for flexibility, for example, then it's useful to have an estimation in real time of the state of the low voltage network. And by combining measurement from smart meters in the low voltage network and measurement at the primary substation in real time, so we have measurement from low voltage smart meters, and we take measurement in real time at the primary substation, so the high voltage medium substation, and we can learn and estimate the real state of the low voltage network by combining those two measurements. Yes, so just to finish, I think I've reached my time, but just to finish, you can find here the references of our project and proof of concept. On the left, you have all the DSO and partners we work with. And at the right of the screen, in the blue circle, you have all the partners and DSO we work with in European or national projects. thank you for your time. Okay, if you have some question, perfect, and I will try to add my camera.
Thank you, Claire.
Thank you. Hello.
Thanks a lot. So I think there are some questions. Bastien. So there is a question from Georgios. Don't you need a secondary transformer sensor for measuring the energy passed from the transformer? And to calculate...
This is a good question. So, no, every information is useful. So if there's a sensor at the transformer at the secondary transfer level, it's good for us. And we'll take the information. But without the sensor, we can find if there are enough smart meters in the low voltage network, we can find the information we need.
Thank you. That's it for the questions. So thanks a lot, Claire. I know you're registered on the B2B platform. So if people want to make appointment with you, I am sure it's possible. So thanks again. And I will now give the floor to a digital company. This is time for My Digital Building. Nicolas Gerchinzon, can you hear us? Is Nicolas with us? Yes, he's coming. Hello, Nicolas.
Hello.
So the floor is yours for a short presentation. Thank you. You can use the arrows to move from one slide to the other.
Yeah, that's fine.
Thank you.
It's working. Okay. So my name is Nicolas Gerchinzon, and I'm the co-founder of My Digital Buildings. So I'm just going to introduce the main problem that we encounter. So what is the common point between all those individuals? Basically, they all interact with buildings during their day-to-day task. And another problem that they are all facing is the search for information and data. And why is it complicated for them to search for information and data around those buildings? It's because the information is irrelevant, outdated, incomplete, unshareable, missing sometimes, or unreachable. This unreachable point, I'm a bit insisting there, because today, with buildings, and especially with the BIM dynamic that is coming around the digital twins, it is quite difficult for people to be able to access to those 3D technologies and 3D models, because you need to have machine, you need to have the right softwares, and you need to have the knowledge to manipulate those data. So this lack of accessing accessible information has a huge cost for organization. It is expensive, it is time consuming, and quite often the data are unreliable. So basically, with My Digital Buildings, we have decided to create an hybrid platform to better exploit digital twins of buildings. So basically what we do is we integrate, centralize, and standardize the spatial data of buildings, and we try to make it accessible to all. You will see after how we do it. Basically, we open use cases for people to be able to enrich and collaborate around the digital twins, meaning that with one digital twin, you can create several use cases for people such as the maintenance, the facility manager, the industrial manager, the marketing manager, for example, to be able to interact with their own way and their own data inside the digital twin. So our way to approach the subject, it starts with the spatial visualization, which is adapted to users and use cases. So we mix virtual tours, so using 360 pictures. We mixed 3D point clouds, 3D models that are made based on the 3D point clouds, and we use 2D floor plans. And so basically we synchronize your the movement that you do inside the digital twin with those 4 elements to be able to easily navigate. So as I said, for the people that are not 3D experts, the virtual tour, like moving inside 3D pictures, is going to be a much easier way for them to use the digital twin data and collaborate inside those data. So it has all the standards for modern application. There's a sentence in French there. So it has a web application for desktop and mobile devices. It's an advanced secured platform. It is ready for integration with other softwares. So basically, we give the spatial data, and other solutions can, with API, connect to the platform and be able to use the spatial data of the digital twin for like softwares such as ERP or technical use inside the building. And basically, the main objective is to make the data accessible to all with easy interactions. So on the top of that, we offer also a turnkey service solution to be able to capture the data of the building. So basically, we have a network of licensed partners that are going on site to acquire the data. So we are mixing 3D scanning technologies and drone to acquire 3D data and 360 pictures. We are able to treat the data in order to create your digital twin for the company to have a ready digital twin to be used. And so our team is made, we were 3 co-founders. So Emric is an engineer specialized in image treatment. Benjamin is a civil engineer with a specialization in BIM management, and myself, I'm taking care of the business part. And this is a view of some of our customers. So basically, we work with different types of industrial customers, some housing, also companies, or some transport or B2B companies. We are part of the Station F Future 40 ranking, and we are based in Grenoble, Lyon, and Paris. And I am available if you have any questions.
Thank you, Nicolas, for this very short presentation and concise. That was the rule. I don't see any question in the chat for you.
Okay. But I'm available later if you want.
Okay, very good. Thanks a lot.
Thank you.
We will now move to the next presentation. It's from Rosso Technologies, which is a startup in the smart grid engineering and software field and consulting. And I will give the floor to Florent Cadou, its CEO. Florent, are you with us? You need to turn on your microphone and your camera, Florent.
Okay, I think I'm good. Can you hear me?
Yes, we can hear you and we can see you. Thank you.
It took me a couple of seconds to figure out how the system was working. Thank you. So yeah, my name is Florent Cadou and I am the CEO of Rosso Technologies. I am, sorry, one more second. Yes, that's how it works. So the company was founded about 2.5 years ago in 2018. We currently employ a staff of 8 people, and we are a highly technical company with expertise in 2 different areas. So one is electrical engineering, and more specifically power distribution grid engineering. And the other area we are expert in is software engineering. So what we do is simply we develop software for the power distribution industry. We have several types of customers, obviously distribution network operators, But not only, we are also working for local authorities, which comes from the fact that in France, the distribution grids are owned by the cities. So the local authorities also have a role in the management of the power distribution grid. Not everything is done by the network operator. And occasionally, we are also working for users of the grid, and more specifically for power producers, because sometimes when they want to connect a new generator to the grid, they also have to carry out their own grid connection study. Okay, so that was the overview. I selected two concrete examples to give you a more practical idea of what we are doing. So the first example is on this slide. It's an example of something mature, something we are already doing business with. Basically, it's part of our commercial offer, and it's decision support software for grid connection studies. So the software is called Ceo. It's our flagship software, let's say our main product. And it goes like this. So let's say you want to connect a new generator to the grid. And this is actually a real example. So it was a 250 kilowatts generator. Then you have to carry out a connection study to check if the grid is able to host this new generator. And if not, you have to decide which reinforcement you're going to make on the grid to increase its capacity and make it capable of hosting that new generator. And on the left-hand side of the slide, you can see the results of the classical engineering studies, the ones that was done manually by the engineer at the DSO, so distribution system operator. And on the right-hand side, you have the same study that was done automatically and in a fully automated manner by our software. And basically, the message here is that the results are exactly the same, almost exactly the same. So the same two locations are chosen for grid reinforcement, and the total length of network to reinforce is also almost exactly the same. So this example shows that it's possible to some extent to automate the work that is usually done manually by the engineers of the DSO for grid connection studies. And this has several advantages. So one is obviously the gain of time, because the software will do in 2 or 3 seconds what a human operator would take a couple hours to do at the very least. And the other benefit is that it makes it possible for non-expert users to do this kind of connection studies. So if you are a power producer or a local authority, you probably don't have the necessary expertise to do the manual study, the manual connection study. But if you have a fully automated software with decision support features, it makes it possible for you to do this kind of study without requiring any advanced knowledge. So that was the first example. I have a second one. So the other is completely different. It's also much less mature. It's still at the research and development stage. And it's software we developed for what's called non-firm connection of generators in low voltage networks. So what non-firm connection means is basically this. So you're going to connect a generator, which is almost always a PV generator in low voltage grids. And you're going to make it flexible, which means that the inverter will be able to receive curtailment set points. So what it means is that the DSO will be able to ask this generator to reduce its production. So basically, you're throwing away free energy when the DSO asks you to do this. And while it might seem as a very dumb idea at the first sight to throw away free energy, it's actually very clever in some situations, because it makes it possible to drastically reduce connection costs and connection delays. So from the economic viewpoint, it makes a lot of sense, and I think more or less everyone agrees about that. But the question is, how do we implement this in a robust and cheap manner? And the way we are planning to do this is by reusing at the maximum the existing smart metering infrastructure. So basically, this project is how to monitor and control flexible LV networks by reusing most of the smart metering infrastructure. And as I said, it's still at research and development stage, but it's still quite advanced. And we have a physical setup here in the lab with real smart mirrors that demonstrate that. And we're moving step by step to a commercial offer with this project. So that's it. I'm done with my presentation. And if you have any question, I'd be happy to answer them. Thank you.
Thank you, Florent. Yes, indeed, there is one question from David. What type of AI methods are you using to automate this type of power grid planification given in example 1?
So I'm an optimization guy, so I'm using a standard method such as, I don't know if the person who asks the question is how expert you are, but basically we don't use the fancy method like neural network and stuff like that. We use good old optimization techniques, and in this case it's linear programming.
Thank you. Okay, no more question. I give it a few seconds delay. No, that's fine. Thanks a lot, Florent.
Welcome.
And we are jumping to the next presentation, and it's by Ryax. It's a data science company, and I give the floor to Yanis. If he's with us. Yanis, are you? Yes.
Hello.
Hello, Yanis. Yes.
Can you see me and hear me? Yeah.
Yes, we see you. We hear you. And can you go ahead with the presentation? You're able to move the slides. That's fine.
Let me check how it works.
You use the arrows down where the page numbers are at the bottom of the screen. Yes.
Yeah. Okay. Perfect.
Thank
Okay.
you.
Thank you very much. Good morning, everyone. So my name is Yanis Georgiou. I'm working as CTO, and I'm also the co-founder of Ryax Technologies. A little bit in contrast with what previous presentations, what we are doing is more on the software side, and in more particularly on the data analytics. Actually, we provide a platform, a data operations platform that enables our clients to industrialize their data science. Okay, so the company has been founded in 2017. We are headquartered on, and we are currently 19 persons working and growing. So let me just give you a brief overview on why the data science is necessary nowadays. Basically, on different studies coming from agencies such as Accenture, Gartner, etc., we see that the statistics say that data science data science projects are going to be one of the main things in the future. So, for example, around 80% of business leaders say that companies that do not get into the big data era will collapse. And another study mentions that 85% of data science projects today don't go as far as production. Okay, based on that, we do see the necessity of doing the project as professionally as needed in order to get the value that we need. Okay. However, another important aspect here is that to go into production is very complicated today. We need 4 data engineers to put the algorithms of one data scientist into production. Okay, and this is something that we at Ryax try to solve. I'm going to explain a little bit how. So if we see the project cycle of data science projects, in general, we start with a proof of concept. We go on the prototype, and finally we advance on a pilot and then into the production side. On the Ryax platform is mainly once we have reached the prototype and we need to go into production, and there are the difficult things that start to happen, such as how we automate things, how we create the actual value in a repetitive manner. How we can automate the different aspects of the data science, how we train our algorithms, how we retrain them, how we measure the drift of our models, and how in the end we continue to create this value. So if we check on what are the different things needed, we need to prepare our code, to integrate it with the ecosystem, to provide collaboration among the data participants, the data project participants, to scale the code, to scale the executions, and also observe and alert in terms of monitoring of our code. Now, what RAEX does is, we take the job of a lot of different software, and we try to integrate it within our platform. Okay, so things such as the integration of the deployment on different infrastructures, or the continuous integration, continuous development, or the orchestration of the actual containers. These are things that we do internally, and if someone needs to do it on their own, they need to actually use all the software that we have in the figure, in order to actually be able to put in production this data science. So in detail, how we create this value, we enable this platform to provide collaboration among data users. We provide ways to integrate with the ecosystem, to provide modularity and reusability of what they create. So things such as connection with external sources to ingest the data, connection to databases, connection to systems such as programmable equipments. All these come through integrations, and then within the actual platform, you will be able to create the algorithms, the code that is needed, and eventually connect them between them with simple to use drag and drop user interface, which in the end will enable you to go and execute these actual algorithms. So yeah, this is a way to see how this how the development teams can go to production. We provide support to Git, which is a way to enter code within the platform, and through this easy to use way to put your code within the platform, and then to connect them between the code between different modules, you will be able to run and automatize the workflows of data analytics. Okay, to give you some of our use cases, we work with different companies and research centers, and I will pass through some fast, and these are my last slides here. We have in predictive maintenance some use cases where we actually do a real-time machine tuning, advising with specific data pipeline automation. We work with Sanofi on the pharmaceutics to interconnect lab instruments, specific sensors to the cloud in order to actually do specific automations in processing. One aspect that I think would be very relevant in our webinar today is our work within the e-mobility, where we actually collect data coming from buses, coming from sensors within buses that go around the city, and this data, collect these sensors collect data from air quality measurements, which are specific, which can be treated specifically within the bus, and eventually the treatment can be moved on clouds or high-performance computing centers to be more precise on the on the actual insight. And RAX actually does the whole orchestration and automation of how these data analytics are executed from the edge, from within the buses up to the cloud and the HPC centers. Let me also give you some other use cases here. We work in the smart agriculture domain for predictive models for food safety, and also in as research with image analytics for real-time image analysis on edge computing. So yeah, that's what I had today. I would be very happy to exchange with you. If you have any questions, I would be also happy to answer.
Thank you, Yanis. Yes, we do have one question for you. The question is, how do you deal with code protection and encryption, which is particularly a problem with Python, for example?
Okay, very good questions, thanks. Actually, what we do within the platform, we do two things. Every code that we deal is actually containerized and brought as a package within an environment so that it can be seamlessly executed on different infrastructures. Okay, that's the first part. And the second part is that we are based on a software-defined networking technique that enables us to do automated encryption of data while they are moving from one infrastructure to another, or while they are moving within their exchange of modules, and this also enables us to have a further security on what are the exact computing resources that we have within the cluster of computing resources that we use. So, for example, if we have a specific edge computing resource, we authorize it to be connected on this software-defined networking or software-defined network, and only authorized computing resources can participate there.
Thank you. Thank you, Yanis. It's time for us to move to the next presentation. So I guess you have understood by now that there is a pattern, one digital presentation and one energy-focused presentation. So now it's time for a presentation from an energy player, Energy Pool, is a demand response aggregator already established internationally. And I will give the floor to Jean Drobowolski. Sorry for that.
It's okay. Don't worry.
And the floor is yours.
Yeah, thank you. Can you hear me?
Yes, very well. Yes.
Perfect.
Fine.
Thank you. So thank you very much for giving me the opportunity to present to you today. Thank you to everybody to attend this presentation. So my name is Jean Drobowolski. I'm working for Energy Pool, and I will try to present to you our different solutions. Oops, it's not moving. Okay, so historically, Energy Pool was created in 2009 in France as a demand response aggregator. And we progressively moved to manage and optimize the energy consumption of industrial sites, and more broadly of complex systems, such as distributed generator, renewable energy, storage asset, and so on, for smarter and more sustainable energy management. So today, Energy Pool has around 100 employees and operates more than 1,000 sites all over the world for around 6 gigawatts of energy under management. Our offer can be resumed in 4 segments. So the consulting services and studies, the offers that we call the active factory offer. So we support, we co-finance, and we collaborate with industries to define a pragmatic strategy for flexibility and sustainability. The EMS, so the Energy Management System, or the DERMS, so the Distributed Energy Resources Management System offers that I will present to you today. So I decided to present this offer today. And the Operation Management offer, so that's the historical offer, which consists of flexibility valorization. So let's have a look of the high-level view of our solution, of our EMS solution. So our EMS or DERMS solution can interface with all these elements. Generation, so we have dispatchable generation and non-dispatchable generation. Consumption, we have industrial load, commercial load, residential load, or we can also call it the critical and non-critical load. All kind of storage. It can connect to the market, so the power market, the flexibility market, and also to peer-to-peer trading and blockchain. And it can integrate a grid connection, so a grid connection to transmission grid, to distribution grid, or no grid connection when we are talking about islanding grid. Even if this platform is can be used in many contexts, so it can be used in VPP optimization, it can be used in hybrid power plant control. I decided to present you how does it work for a microgrid. So let's have a look on this solution. So on the right part, you have a typical microgrid with some assets. We have some renewable generation. We have some storage. We have some fuel-based generation, some residential load, industrial load, and we have a grid connection. So the control proposed by Energy Pool can be, we have a two-level control. The first one is the one that I already presented, so the EMS platform that is stored in the cloud. So how does it work? We have, let's say, 3 different modules. The first module is called the forecast module. So through a connection to weather forecast, we are able to do a long-term forecast, so 24-hour or 24 or 48 hour. And through machine learning methodologies, we can forecast the load consumption and the electricity prices. The second module on the left is the module that we can call the customizable one. So we can customize the microgrid topology, we can customize the equipment characteristics, so it can be the size of renewable, it can be the size of a circuit breaker, it can be if we allow or not to export on the main grid, it can be the size of the batteries, the ramping of some asset, and so on. And we can also customize the operation guideline. So we mean what is required by the owner or the operator of the microgrid. Then some actions are possible from the operator. So it can be, so the operator can plan maintenance, for example, or it can plan the electricity price, it can connect the electricity markets. And finally, the third module is the so-called, the one that we call the forward-looking optimization module, which aims to calculate the optimized profile for the next 24 or 48 hours with a customized sample rate. So once this optimized profile is calculated, it is necessary to have a local gateway to control the assets. So this is the role of the second level of control that we propose, which is called the Microgrid Controller, but we can also call it the Power Management System. So because it will deal with power, on the contrary to the EMS, the Energy Management Systems that deal with energy. So the Microgrid Controller aims to adjust control assets according to real-time monitoring while respecting as much as possible the EMS profile. So at each time step, one more time customizable, the measurements are sent to the EMS, which redo the calculation and resend an optimized updated profile. So the Microgrid Controller will also ensure the protection features, and it can manage the synchronization or desynchronization from the main grid. So what is important to know is that Energy Pool can either provide both level of control, so number 1 and number 2, but it can also provide only the EMS platform, which will be connected to an existing microgrid controller. It can provide, or we can provide the EMS platform plus a small PLC that we internally developed to connect with an existing microgrid controller through Modbus TCP or Modbus serial. And we can also provide the microgrid controller, so a local microgrid controller, which will include what we call the rule-based control, so without any forecasts. And yeah, that's all for this this presentation. Please do not hesitate. If you have any question, you can ask it through the chat, or here are my contact details.
Thank you, Jean. I do not see any question yet.
Yeah.
So feel free to ask your question in the chat now if needed. Otherwise, I will thank you for this presentation, which
Thank you very much.
highlighted a different offer from Energy Pool than the one we are used to. To seeing. So nice to see that you're enlarging your offer. And I will give the floor to the next presentation. Thank you. So our next speaker is Gauthier Chicot from DiamFab, the Diamond Technology. So Gauthier, can you hear us? Can you turn on your microphone and your camera, please?
Yes. Can you hear me?
Yes, very well. Thank you.
Thank you.
The floor is yours.
Yeah, thank you. I will try if I can change the sides. Perfect. Thank you. So I will introduce you DiamFab. So we fabricate diamond as the next generation of semiconductors. But first of all, I would like to introduce you our team on support. So DiamFab has been founded 2 years ago and is a spin-off of Institut Néel CNRS. And I'm Gauthier Chicot, so the CEO of the company that I co-founded with Frederick Lux, the CTO of DiamFab. Our scientific advisor, world-class scientists, are also co-founder of the company. And last but not least, Cyril Menon, who is the executive vice president at Soitec, is bringing his valuable advice on management and industrial issues. Oh, sorry. So in fact, as well as other industries, electronics is concerned by macro challenges. Power electronics in particular must be a way to reduce the impact of human activities on the environment without slowing down the technological progress, especially in electrical grid, where power devices are in every node of the grid. And these devices are made of semiconductors. And semiconductor industries is facing a relatively new problem. Silicon, who is mainly used, is now showing its limit to deal with more electrical power. That's why, in fact, we are looking for new semiconducting material to replace it. Among them, diamond is recognized as the ultimate semiconductor thanks to superlative properties, such as its ability to withstand higher voltage, 30 times higher voltage than silicon. So that's very interesting for electrical grid. And concretely, diamond devices could allow reducing volume on the weight of electrical converters for electrical mobility, for instance, could also allow high temperature and high radiation operation, and especially interesting for the grid, the electrical grid, could allow also high voltage operation, for example, for new HVDC electrical grid. And last but not least, diamond is also a good candidate for fast emerging quantum application, but it's not the topic of the discussion today. And some slide is missing, but okay. I don't know why, but I can. So in power electronics, silicon replacement already begins. In fact, silicon carbide on the. I'll try this slide. Silicon carbide and gallium nitride are being adopted by the market, and now it's time for diamond. But in fact, diamond is not a semiconducting material like any others. What makes its strength is also an obstacle to synthesize and adopt it. This is where DiamFab come in with its solution based on 30 years of R&D. Conducted at Institut Néel, so the laboratory of CNRS, and protected by several patents. And what we do more precisely, DiamFab is specialized in diamond epitaxy, so the fact of growing diamond on a substrate. And epitaxy, in fact, is a key position in electronic value chain. And this is particularly true in diamond because there were no commercially available solution. And epitaxy bring almost all the final devices performances through in situ doping, for instance. So the way of conducting properties to the material. So our business model is based on that. So we plan to fabricate and sell high-value diamond wafer to foundries and also manufacturing processes for diamond components that we have patented. So concretely, we synthesize and dope diamond epitaxial layer with a unique control in the world. So therefore, we are able to go from a diamond substrate with no electrical properties included to a wafer ready for devices fabrication with active layer included and electronic grade. So the layer are electronic grade. We offer then a turnkey solution to material plus process with a high quality that will ensure the highest electrical performances for the final devices. And our diamond wafer are customizable thanks to our expertise, so we can adapt our wafer to various domains of expertise of application, especially in power electronics. And last but not least, our diamond wafer contribute to energy sobriety, allowing, in fact, the fabrication of more efficient electronic devices made out of diamond synthesized with hydrogen and methane mainly. And just to finish, we are already selling our product to R&D actors thanks to our network, and we are now targeting to sell our product to industrial players thanks to our expert position. Today, our customers are mainly in USA and Europe. And Europe especially is a favorable environment for faster development because of new policies for sovereignty issue in semiconductor industry, and also the strong interest for smart grid and new electrical grid. And in fact, we are convinced that our technology is very promising for smart grid, and we are looking for opportunity of collaboration to accelerate the development of diamond sector, so diamond semiconductor in power electronics in the new electrical grid. And just to conclude, so to go further with diamond, let's go together. And so feel free to visit our website to learn more on our technology, send me an email, or just ask your question in the chat. Thank you.
Thank you, Gauthier, for this very interesting presentation. I do not see any question yet in the chat. So
I must have been very clear. So thank you.
Thank you. I will go now to the next presentation, back to energy, with a presentation from one of our members, Automatique et Industrie, AI, David Hernandez, who is an R&D engineer. David is connecting. Hello, David. Can you hear us?
Hello. Yes. Can you hear me?
Yes, very well. Thank you. So
okay.
The floor is yours.
Okay. Thank you.
Are you able to move the slides? Yes. Very.
Okay, it's fine. Okay, thank you very much. Thank you for the invitation. My name is David Hernandez, and I will presenting you some of our solutions on smart grids. So I'm with Automatique Industrie. So we are located near Grenoble in the French Alps. So our company has an historical activity on industrial automation and energy management solutions. We have a specialized team of collaborators in industrial programming, PLC programming, SCADA implementation, and so on. And these solutions are applied to a wide range of industrial applications. In recent years, and driven by this 6% investment on R&D, we have developed some solutions, for example, for the energy efficiency market. But We can also propose today more advanced solutions using data science, machine learning, and robust process optimizations. And a result of some of these solutions for smart grids are, for example, applications to automatic predictive maintenance. We also have a solution to optimize hybrid power plant equipment maintenance. And a second proposed solution from this R&D activity is a complete intelligent energy management system, or EMS, as we have seen in the previous presentations. And this is applied for hybrid power plants with solar batteries and diesel generators. And we are mainly focused on off-grid applications. So for most of our R&D activities and byproducts of these activities, we really focus on mastering the data flow analytics, the data analytics flow. And this goes from data acquisition and passing by database management, data cleaning, and finally actually using the data with machine learning algorithms, and all this in a production-like with a production-like approach. Our main focus here lies within the integration of data analytics in the many different applications of the energy sector. An important approach for us and for our solutions is the data-driven virtual twin concept. And we apply this to model the hybrid power plant and the microgrids based on measured data. And this has the advantage to catch important features in equipment, such as, for example, the battery aging, which otherwise is very challenging to model using physical and empirical models. And well, then the virtual twin here for us is a key part of our EMS and a key part of our other solutions, such as the predictive maintenance and intelligent reporting solutions. So our focus on smart grids is mainly driven by the experience we have on real field applications in automation and our know-how on data flow treatment. And this means, well, working with communication networks, database management, efficient back and front-end solutions. In the context of the smart grids, and more specifically in the microgrids, our solution scope will lie within the tertiary and secondary control levels, shown here on the right. And for example, for our EMS solution, we will have several entities that will interact in these two control levels, so tertiary and secondary. On the upper level, the data analytics is used to propose an optimal operation of the hybrid power plant. And in this kind of solution, the virtual twin of the system will help us to implement robust optimization strategies to attenuate the system uncertainties, such as the weather, the data, the power consumption also. And to implement these solutions, we strongly rely on our extensive field experience on automation and real-life system control. So we will propose with this solution a high level of availability, using reliable communication architecture, redundant loops, and efficient PLC programming. So an example of a real architecture solution is shown in the right. And finally, an important step for us in early stage of development of this kind of product is to validate our solution on an environment as close as possible as the real system. So for this, this allows us to advance on the TRL scale of our product development. And a method for this is what we call the HEL, the hardware in the loop testbed platform. And this is a validation approach that is using real-time simulations of the hybrid power plant, and thus validating the behavior of the real physical components used in our solutions, such as the PLC power plant controller, or the PPC, and well, even validating the energy optimizations proposed by our machine learning algorithms and by the robust optimizations. So that's the end of the presentation. If you have any question, I will be pleased to ask to answer. Sorry.
Thank you, David.
Thank you.
I do not see any question for the moment. So thanks for the presentation.
Thank you.
And I will give the floor to the next speaker, who is Isora Vachaud from Cybersecura. So the name of the company is self-explanatory. We're going to talk about cybersecurity. Is Isora with us? I don't see her on my screen.
Hello, can you hear me?
Yes, hello.
You can hear me, you can see me, hello.
Yes, hello Isora, welcome.
Thank you.
So I give you the floor. You are able to move the slides in the presentation. Can you check? Yes, fine. Thank you.
So, good morning, everyone. So, to quickly introduce myself, I am Isora Vachaud. I'm a master's degree student, and I'm working as a marketing manager at Cybersecura, a French Grenoble-based company dedicated in consulting and services in cybersecurity. I'm very happy, a little bit stressed, but very happy to be here today to talk with you about the smart grid security-related issues. So, to quickly introduce the context, let me show you this graph. It represents the number of attacks the French national energy network suffers per month. So we could notice the numbers are huge, but also that they are constantly rising over the years. Historically, the main challenge for energy providers was to ensure stability of services, but the evolution of the energy market is now moving toward greater efficiency and speed. The pursuit of these new goals through smart grids should not be seen as a step backward and the loss of stability, which is a possible risk given the attacks that smart grid can suffer. And the threats that smart grids face are numerous. These threats can be technical or legal. To name just a few, smart grids can be affected by denial of services, which is the most obvious attack against an energy provider. This kind of attack, if not properly anticipated, may completely stop energy providers' production and distribution lines. Viruses as well are becoming a threat. As the network is getting more and more digital, it inherits from the general IT weaknesses. Legal security obligation might be a business threat for smart grids. In France, for example, vital operators are legally obliged to meet high standards of security if they want to access the market, to ensure a good level of services and a protection for the users. Another challenge for smart grids could be legislation. As they often deal with many personal data that can be collected through smart meters, for example, they must be compliant to GDPR, for example. In relation to all these challenges, what we propose and recommend is that you be accompanied by cybersecurity experts, if you do not have any in your company. That's why at Cybersecura, we are fully dedicated to help organizations from all types and sizes to protect their users and to secure their future. We are fully dedicated to expert services in cybersecurity and compliance, and we are working on both security and privacy aspects. Our 360-degree expertise allows us to work on cybersecurity as a whole: IT, softwares, application, IoT systems, governance, compliance, training, data protection, and so on. All kinds of elements that could be involved in smart grid systems. This slide shows a few of our clients. So we have been working with a multinational company like Sodexo, with a software editor like Bonitasoft, with startups as well, such as Morphosense and T-Hive. And we already worked with an energy provider, GEG, which is the Grenoble-based energy distributor. Our company is referenced by the government as a cybersecurity stakeholder in France, and we are certified Azure Security Engineer Associate. And we are actually we are currently, waiting for the validation of 2 other security certifications that are AWS Security and ISO 20000 family. So that's all for my presentation. Thank you a lot for your attention, and I'm available if you have any questions.
Thank you, Isola. You did very well. Congratulations.
Thank you.
I do not see any question in the chat.
Okay.
So I guess I will move on to the next presentation. Thanks a lot. For sure, cybersecurity is an important topic related to smart grids, so not surprising that we have a presentation on this topic. And I will move now to a presentation by Rémi Perroni from Kaeli Energy, which is a young company developing high energy efficiency air conditioning systems. Rémi, are you with us? Can you turn on your camera and your microphone, Rémi? I see Rémi, but I don't hear him. I see him in the list of people attending. You need to allow your camera and your microphone to be used by this application. I guess Rémi disconnected and reconnects. Rémi, can you allow your microphone and your camera to communicate with this application? On the top, yes.
Hello.
Yes. You made it.
Yes, perfect.
Thank you.
Shall I go?
Yes. Are you able to move the slides?
Can you do it for me?
Okay.
Okay, so good morning, everyone. My name is Rémi. I'm the CEO and founder of Kaeli Energy. I'm really glad having the opportunity to present our company. And we are specialized in the manufacturing of low carbon air conditioning system for residential application. Next slide, please. Thank you. So, as you know, summer are becoming increasingly hot, and modern housing is not well adapted to the heat. However, residential air conditioning has a poor image environmental. In fact, AC has a huge environmental impact, consume a big amount of energy, and release greenhouse gases. They release pollutant refrigerant fluids. Moreover, it's often impossible to home because of the condominium or urbanism regulation, visual or noise disturbances. Okay, next slide, please. Perfect. So our value proposition is simple. We are developing innovative and low carbon residential air conditioner, 3 times less energy consuming than a classic AC, which do not need any refrigerant to operate and do not increase the urban heat island effect. So based on the same technological developments, we are launching 2 product range, the Zephyr range, a mobile AC, cooling capacity between 1.5 to 3 kilowatts. It will allow to overcome a temporary thermal discomfort in a dwelling. And the Pampero range, wall-mounted AC, more powerful, cooling capacity between 2 and 5. Next slide, please. Perfect. So we have developed a high-performance dew-point evaporative cooler. Our technology is based upon an in-house compact heat and mass exchanger coupled with an innovative thermodynamic cycle, Mazotsenko cycle. Our technological development is made in partnership with the French Public Research Lab, specialized in energy and buildings, the LOCI in Chambéry. And we have been awarded Deep Tech by the French Public Investment Bank. And our innovation is based on the development of a new exchanger architecture and the development of ultra-thin plates with integrated capillaries. There's innovation allowed several technological improvements. First, the size is really reduced. Our exchanger is 4 times more compact than the direct competition. We have increased energy and thermal performance respectively by 60 and 20 than the direct competition. Next slide, please. If we look at our competition, and especially in Europe, we are mainly competing against conventional AC, mobile AC for the Zephyr range and conventional wall-mounted AC for Pampero. I won't go too much into details concerning our competitive advantages. What I suggest you to remember is that our main differentiation is our environmental footprint. Low energy consumption, low carbon impact, and no increase of urban heat island effect. Yeah, next slide, please. And just to give you a brief overview of our team, it's quite good. We are located in Mélan, near Grenoble, and I think a big part of our development now is due to our capacity to have a nice ecosystem around us. We are dealing with R&D research lab. We are dealing with industry specialized into prototyping. We're also talking about market contract with other industry player. And we also incubating in CSTB in France with the Center for Scientific and Technical Study in Buildings, specialized into the reduction of norm and certification. Thank you.
Thank you, Rémi. I don't see any questions for you. I hope our listeners are not getting sleepy. I know it's very intense sequence of presentations, and I can reassure you we will take a break after the small pitches, very small presentation, and before the next ones. So thanks, Rémi. No question for you. It's all clear. And moving on to the next presentation. Thank you. So I will now give the floor to Patrick Polsch from ED, which is an energy marketplace company. Patrick, can you turn on your camera and your microphone? Thank you.
It's okay? Yeah.
Yes, absolutely. Thank you.
Okay.
Welcome.
Hi, everybody. Welcome. I am Patrick Polsch, the General Manager for ED and founder for ED. It's a great pleasure for me to introduce you the solution from ED for sustainability in this webinar. So I have 2 solutions to present you. Sorry. Oh, here. It's okay. Oh. Yeah, we have 2 milestones, which is EGO. The solution EGO is local renewable energy certified by blockchain certification with proof of stake consensus. It's consortium energy blockchain. It's the way to provide energy, renewable energy to companies with certitude, traceability. And our mission is to enable professional customers and businesses and local authority to embark on the path of green energy consumption with the proof of stake with consensus raft in Quorum in Ethereum. And the second solution milestone is energy consulting services and connecting low carbon project with experts. It's an energy marketplace for low carbon way for SME in France. And in the memory, the first milestone is for international market, not probably in France because of decarbonation with nuclear energy. So Sorry. The first one is EGO. As I said, it's to enable professional cluster and businesses and local authority to embark on the path of a green energy consumption. Thanks to EGO solution developed by ID, customer will now be able to choose the energy sources best with of their needs. The technology, hydro, photovoltaic, wind, marines, biomethane, hydrogen, the geolocation of the site, producing the energy from the portfolio of renewable assets of producer registered on EGO in order to further a supply close possible than their consumption sites. It's available with pay-as-you-go in smart contract execution with consensus in sobriety, energetic sobriety, and it's developed for a big firm in international market for the India and the China or South America market, for companies like Saint-Gobain, Orange, like others, big industrial firm. And it's a good way now to be in a real execution for a sustainable way and for industry to have a low carbon footprint with the sourcing of energy. Here is the graph with the system of EGO, which is provided by producer and multi-producer with others actors in energy supply chain like DSO and transportation of energy, and provider for the supply chain of companies, which companies can be also prosumer and be producer tomorrow. And we digitalize the PPA, the power purchase agreement, inside the solution EGO. It's at this day, it's a prototype which was made with a big ESN, which is Ineton, and we made a proof of concept during 5 months with big company like SmartEnergy, like Steph Logistic and Ekiom, and they sponsoring the solution with RTE and Enedis, and we work now to be interoperated and on the French market with Enedis for a big company to make POC in France and to develop for international market. How it works, by your site, you can decide to supply to take your choice from energy, and from site that you decide the geolocation, and you can decide the technology and the volume that you want to implement it in your energetic mix, and you have the way to register in continue at 10 minutes step, and you can see your mix, your energetic mix, in a continued way in the week or in the day for your energetic mix, and challenge your consumption with a new energetic mix with sustainable sourcing in marines or electricity, gas and marines, photovoltaic, wind turbine, or others energy consumption. Here is the world system with guaranteed origin guarantee of origin system in the world, and many people buy their energy with energy guarantee of origin system. But now our system reconciliate the energetic workflow with the contractualization workflow inscribed in the subscribed in the register. So it's a big way to be on reconciliation and to improve the renewable energy consumption in each countries that we want to go now. There is more advantage to go to the solution and the benefits for corporate and producer. It's many way to be in the real way to be sustainable for tomorrow. It's okay for me. Thank you, Patrick.
We do have some questions for you, so not everyone is asleep. Thank you. Frederick has a question. What is the energy consumption of the blockchain operation itself? And is it also a green operation?
Yes, we in the conference that we made on the POC, proof of concept, that we decide to be on the consensus with token ERC 223, which is energetic sobriety consensus and token, and with a consensus draft, which is the constitution is like your mobile phone. When there is a transaction with 1 megawatt-hour injected on the network, there is one unique transaction with 1 megawatt-hour consumption from the company, and it's a pay-as-you-go. And when there is no injection in the system, there is no power or consumption of the system. By the way, there is another protocol that we need on the blockchain system. It's to ensure that the system is not with crypto money. There is no speculation, and there is no calculation power consumption. That's why we are in the big coherence with the mindset of the system.
Thank you for this answer. There is another question. Do you have any indication of performance improvement of proof of stake versus proof of work?
Yeah, the proof of stake is just we choose the proof of stake because it's with consensus in energetic consumption, low energetic consumption way, and there is a proof of stake because it's a consortium blockchain, which inside we know everybody, we know every members of the blockchain inside the blockchain, and every members is proof his role in the blockchain with his rules, his property rules in the system. That's why we make the choice with proof of stake versus proof of work, which is big consumption of energy, like Bitcoin, for example, or Ethereum 1. And now we examine, we want to explore the Ethereum 2, which is in proof of stake versus proof of work in the first version.
Thank you, Patrick. This is becoming very expert talks. So thank you for going into the details of the answers to the questions. And we will move now to our next presentation, which is the last one of the flash presentation by SMEs, regional SMEs. And the floor is to SmartEnergy, a software development company for making decisions in new energy systems. Jean-Luc is joining. Hello, Jean-Luc.
Hello, do you hear me, Ingrid?
Yes, very well, thank you.
Okay, thank you.
Welcome.
To move the slide. Yes, it works. Perfect. So thank you very much and good morning, everyone. Thank you, Tenerrdis and Minalogic, for this invitation. And I'm very happy to be with you this morning. And I have the privilege to finish this series of very interesting presentation. So I'm Jean-Luc Picot. I'm the Deputy CEO of SmartEnergy, a French company based in Grenoble I co-founded with Benjamin Guinaud 4 years ago. And we are a software editor. We develop and market the software Odyssey. SmartEnergy is a spin-off of the CEA. CEA is the French National Research Center, and we have inherited a strong multi-energy expertise. So we are experts in techno-economics and modeling of energy systems, any kinds of energy systems, off-grid or on-grid, off-grid, etc. Smart grid technology specialist in production, storage, uses, etc. And our willingness is to help energy actors assess the profitability, environment, benefits of their energy systems. So basically, we support our customers and partners in their investment decision in these 4 main steps: how to make the right choice of technologies and applications between, for example, hydrogen, electrical storage, etc. How to optimize the sizing of each component, the production, the storage, electrolyzer, etc., etc. And how to optimize the control strategy of the systems, or how to make the right operation decision at the right moment. For example, when should energy be stored and on what criteria? And of course, we help our customers and partners to carry out the technical, economic, environmental feasibility study of their project. So for that, we develop and offer the software Odyssey. This is the tool for decision-making and investment in new energy systems. Odyssey has been awarded by Solar Impulse Foundations in 2019, and also, of course, by Tenerrdis in 2018. So how it works, very, very easy to understand. Odyssey builds a digital twin of the system, photovoltaic, batteries, fuel cell, electrolyzer, heat pump, etc., and uses it in dynamic simulations to give an insight of its operation over several years. Combines with the use of artificial intelligence, we use genetic algorithm, machine learning. Odyssey optimizes the sizing and the energy management strategies of the systems. And we also had a sensitivity analysis tool to help to, let's say, identify the most impacting factors on the economic and environmental balance. For example, what are the consequences on the project if the price of a PV panel varies by more or less 20%? So what are the benefits when using this software? Odyssey is a user-friendly tool, so you can take control and master it in only 2 days. You can perform a complete technical, economic, and environmental feasibility study of your system in total autonomy. And you have access to all the technical and economic required dashboard of your project, the NPV, cash flow, ROE, etc. At SmartEnergy, we are convinced that the development of smart grids can be done not only with electrical microgrids, but also by considering multi-energy microgrid. And for that, I would like to illustrate and to share with you a typical example of a multi-energy smart grid, for example, from an eco-district studied with the software. This multi-energy smart grid is composed of 2 renewable sources, PV and wind, an electrical load, an electrical storage, the connection on the grid in extraction and injection, a hydrogen chain with an electrolyzer, a compressor, storage, and a fuel cell, and a heating network with a heat pump, with a thermal storage, and domestic hot water and heating demands. And the objective of using the software Odyssey in this case is to try to find the autonomy of, for example, a set of buildings, autonomy in electricity, in domestic hot water and heating, including the production of renewable electricity, the production of heat, and several storages. And in this case, ODC can be very helpful to answer those questions. What compromise between electrochemical storage and thermal storage? And I could add how to valorize the capability of hydrogen to store energy over long term. What is the technical and economic interest of using the heat from the fuel cell and, of course, also from the electrolyzer? And, of course, the main point is what energy autonomy rate can be reached at a reasonable cost. So here, that's all from my side. Do not hesitate to ask us, to contact us for a demonstration of the software in several cases. And of course, visit our website. You can find many case studies. And of course, I'm available to answer your question.
Thank you, Jean-Luc. Let me join the chat. I think we have some questions. Oops.
Let's go, Ingrid.
Do you have an indication of performance? No, sorry, that was the last one. I'm sorry, my mouse is very...
Yes, I think the question is about the real-time mode of ODC or not. Yes, of course. This tool is basically, yes, the first use of this tool is to carry out a feasibility study, but we can, and we did it by the past, we can put this software in a real-time mode. Means that ODC can send to PLC, to different automats, some of output results coming from the simulation process. To manage, of course, installation. We did it for electrolyzer, for fuel cells, for different components of hydrogen chain. So yes, ODC is able to manage, to operate real and physical installation, and we can provide ODC with data coming from monitoring. So it can be very relevant to use this real-time mode using this software.
Thank you for the answer to the question. There were more questions. Sorry. So the one, how long does it take to set up such a study?
Not very long time to set up all parameters. When we provide the software with our customers and partners, we help them to, we provide the software with generic data. So basically the user can start the study just after the training period. And the training period is only for 2 days, like I was saying before. So yes, after this training period, the user can use the software because the software is provided with generic data for all components, for example, for batteries, for fuel cell, heat pump, etc. So this is the setup of all parameters doesn't take no more time.
Okay. Thank you. And then another question, are there some general conclusions of the most appealing business cases?
Yes, of course, the goal of this tool is to help the user to take right decision on investment. So of course, the software provide many different kinds of economic data, a business plan over several years. For example, usually we calculate the business plan over 20 years, 30 years, etc. So after the simulation process, the user have access all, let's say, the main information to take a right decision on investment.
Yeah, I guess the question is more, do you see some general conclusions like, I don't know, adding battery is always relevant, or adding hydrogen combined with, is there something really that is common as a conclusion to many different business cases?
Yeah, of course. The use of the software can help the user to compare, to test, to evaluate different scenarios, to add batteries, to do not have batteries, to add a hydrogen chain or not, etc. It's very easy to compare different scenarios. So this is why this software is mainly used. So yes, after the simulation process, you have all the data, once again, to compare, to analyze different scenarios, adding or not batteries, adding or not, let's say, thermal component, etc., etc. So it's very easy to add a new component in a system, in architecture. We have developed all the components for any kind of energy systems nowadays.
Okay, thank you. Another question, can you provide services to public services, urban collectivities, for example, or energy syndicates, syndicat d'énergie en français?
Yes, okay, of course. Our many customers and partners are probably more involved in renewable energy project developers. But we are local authorities are customers of us. For example, EPA of Saclay in French, EPA Saclay, uses our tool to help us to help them. To simulate their heating and cooling network. So yes, we can provide the software with public services, etc. No problem.
Okay, thank you. And I guess that's it now.
Okay, thank you.
So thank you, Jean-Luc.
Thank you.
Yes, so we are a bit ahead of our schedule, which is very nice considering the number of presentations that we had. So we thank all the speakers because they really did a very good job at making concise presentations. And now we will go ahead with a presentation from Flux 50, Frederick Lux, about smart grid connections in Flanders, in Belgium. So Flux 50, as I remind you, is a partner of our European project. So Frederick is with us. Thank you. Can you hear me, Frederick? No, but I don't hear you. I see your mic is on, but I cannot hear you. No. No, we cannot hear you. So maybe we take...
Is it now better?
Yes, it's good now.
Okay.
Good.
I found the magic button.
Yes, thank you. Great. So is it okay for you as well to, yes, move the slides? So that's perfect. I can leave the floor to you, and please remember to make a focus on, smart grids in Flanders. That's what is of most interest to our attendees. Thank you.
Okay, thank you, Ingrid. Actually, to start presenting myself, I'm Frederick Lux. I'm responsible for a cluster in Flanders called Flux 50, which is mainly targeting on energy. And we are coming out of a former organization which was actually called Smart Grids Flanders, and in which we only had a focus on smart grids. So it's very nice to see the topic still going on, and be able to present to you a little bit on what is going on in Flanders. Perhaps to start with, what is our reason of being as Flux 50? It's quite similar to Tenerrdis. We are a cluster organization orchestrating and facilitating the cooperation between companies within the Flemish region. Our intention is to show that, of course, Flanders is a good region when it comes to smart energy and a good place to be in to create some proof of concepts and to help companies, always with the aim to create economical value. So we are mainly dealing in a triple helix structure. So bring together companies, research institutes and governments in order to create that that vision of the future, to call it like that. We are a non-for-profit organization, a member organization. We have around 216 members at present, and all those members pay a certain fee. And then we get from a Flemish government, we get another euro for each euro that we get from that membership fees. So in total, we are working on an annual budget of around 1 million euros. So I employ around 10 people also in order to get the ecosystem in Flanders running. Next to that, financial support for the organization itself, we also channel quite some innovation support to the industry. So in total in 2020, we were able to channel around 16 million euros of grants, of subsidies by the Flemish government to the Flemish industry. From time to time, most of the time in projects that are going on in Flanders itself, but also from when it's possible in cooperation with other companies from abroad, from clusters like Tenerrdis, from Cluster Tweet. So whenever you see some possibility to cooperate or to set up something in the Flemish region, please do not hesitate and contact us. As I said, 224 members. We are a growing community, a mix of, just like I heard here, small companies, small, medium-sized enterprises, startups, together with, of course, the large ones like ANG, the Schneiders, the ABBs that we were also able to hear during the six-pack. We do have 3 pillars that we help our members with. One is on providing information. So just like we have here the six-pack on smart grids in the Flemish region, together with the Cluster Tweet, we're performing the six-pack on energy communities. Yearly, we have around 10 to 15 information sessions. Of course, in these COVID times, it are mainly virtual sessions. But we would be happy to invite the ones that want to come to Flanders for a conference or a physical six-pack session. We'll be happy to host you, to create contacts for you within the Flemish region, with our member companies, help you with the legislation that is present in Flanders. So those are all kind of things that we do under the pillar of information. Of course, we help people and companies to innovate. Our focus is not that much on innovations done by one company on itself, but rather on successful cooperation between different companies and different entities, as you will see also in the case that I will present later on. So we are mainly working on projects which have at least 3 partners participating, because we do believe that in a complex system such as energy, a lot can be learned and gained by working together. And last but not least, we also have some activities on internationalization. We go together with our Flemish companies to trade fairs, we organize missions, and also as Flux 50 ourselves, we are engaged in quite some international activities. But I will not dive into detail on that one, because I do think that the emphasis today is on smart grids. And smart grids is one of our 5 innovator zones. So all our projects are categorized into 5 different topics. we see three different, let's say, markets: energy harbors, so large-scale energy production, multi-energy on a district level, and intelligent renovation, so more on the residential or the building level. And then we see two different topics which are really cross-cutting and which are needed in each of those three markets. And one of them is microgrids or smart grids, or how you want to call them. And along with that goes also the energy cloud platforms. So I was also very happy to hear that there is also something going on cybersecurity within the Grenoble region, because in that energy cloud platform, we also have quite some focus on cybersecurity, together with artificial intelligence, together with a focus on everything which goes along with privacy. So you can see that those 5 innovator zones, they are virtually put next to each other, but you can clearly see there are very strong and necessary links between those different focal points of Flux 50. Just to give you an idea on the topic of microgrids, last year we funded 2 projects. So in 2020 we funded 2 projects on the topic of microgrids, with a total volume of 2.5 million euros going to that topic. And on the entire lifetime of Flux 50, because we're only present for around 3-4 years now, in total we had around how should I call it? We had around 14 projects with a total budget of 15 million euro and a support by the Flemish government of around 8 million euro. So that's more or less the importance of the smart grids or the microgrids topic within our portfolio. It's around 1/5 of total number of projects and the number of subsidies that go to that particular area. Today, I want to take you to a project that we are financing in industry. I heard a lot about energy communities and smart grids. I heard a lot about renewable energy and smart grids. It's all hot topic. But I want to, when we were searching for the one project to present here today, I thought it would be good to also make a match to what industry and process industry can also benefit from a thing called microgrids or smart grids. And in this particular project, we have a cooperation between, on one hand, companies, Imtech as an integrator company, Bekaert as a steel fence production company, BASF. I think it's quite known as the big enterprise in the chemical industry, together with Blueways, which is a very small local enterprise on let's say supercapacitors and battery systems, and they are collaborating with Flanders Make, which is a research center on really the process industry when it comes to the make industry, and then the University of Leuven. And together they are investigating how they can DC-fy a production process. So as you may know, a lot of the production processes are at this moment fed by alternating current systems. Also our entire system, our entire energy system is on AC at this moment. Actually, it was a war at the beginning that was between alternating current and direct current energy systems, distribution systems, that has been won by the alternating current paradigm due to the better way of securing it. So the fusing technology for AC is a lot easier than when it comes to direct current. But we see that a lot of the generation as well as the motors are in theory, are in practice actually DC machines. So we want to investigate what is needed and what are the benefits from removing that AC system again and really moving to a DC backbone from the beginning of the end. What do we want to achieve with that? We want to increase the efficiency. We want to have, because we have less components. We want to have an enhanced availability. We also want to reduce the harmonic pollution. I don't know how it is in France, but in Belgium we do have very strict regulation when it comes to connecting your system to the grid. We do see that there is a lot of problems when we are in process systems, so there is also a gain to be investigated when it comes to reduction of those harmonic pollution. And we also want, as said, to have less components so that the power conversion capacity in total can be lower, which should lead in the end to a total decrease in the total cost of ownership. We are testing out different DC architectures, also different DC voltage levels, because there is still no standard on the DC voltage level. So we are all used to the 230 volts when it comes to the AC and to the 50 hertz, unless you go to other places in the world. When it comes to DC, the main architecture and the voltage levels are not yet fixed. So we are there also testing out what is an optimal level. Also, when it comes to integrate storage modules, batteries, supercaps, and other things into the system. In the end, the idea is, or the KPIs they are working on, is to reduce the total factory's electricity-related system losses, so the conversion losses, by around 5%. There is still the need to do some conversion of electricity because not all of the systems, as there is no standard yet on a DC bus, are running at the same DC level. So we are experimenting there with multi-port DC-DC inverters and those kind of things. The total harmonic current distortion at the common point of coupling, which is mainly the grid connection, needs to be 50% lower, removing the need to have other systems trying to rebalance that current distortion. So that there are fines, at least in Belgium, there are fines on the company when you have a current distortion which is too large. So you also always do a compensation, and when we are able to diminish that the height of that compensation, it also saves capex. So also the voltage unbalance factor at that common coupling point needs to be decreased, and it leads to at least meet the capex of a reference AC alternating current grid. But in fact, we would like to see a diminishing of the cost by around 10% compared to a traditional AC grid. What is making it there a little bit difficult on the investment cost is that most of the inverters I'm talking about are not yet common practice. So that makes that, due to the economies of scale, that the typical equipment is at present still more expensive compared to the AC alternative. But it's not only about really enhancing that capex and decreasing system losses. It's also about increasing availability, especially when you look at the process industry. They don't want to have any downtime. They want to avoid production losses as much as possible. But you see that also the UPS, the uninterruptible power supply systems, are typically running on DC. So we have there also components that we can remove, critical components that we can remove in order to, on one hand, have a swifter take-up of that backup capacity in cases of power outage. And on the other hand, also are able to remove there some components in order to decrease the cost of the entire system. And I need to say that when I talk about we, I mean the participants in the project, because in Flemish projects, we as a cluster, we take the role of facilitator, but we are not conducting any research ourselves. So when I say we, I actually need to say the consortium which is behind the project. Total, there has been a budget foreseen of around 3 million euros and a subsidy of around 1.5 million euros. So you can see that's also on average what we are able to have as a subsidy rate is between 50 and 70%. And the project is actually running still, so I'm not able to show you any results yet. We hope that we might be able to do so within half a year or something, some intermediate results. But it started the 1st of February last year, and it will run until mid next year. And of course, with all the Corona stuff, we also see that there are, in such a project, also some delays that we need to take into account. This was a focus on one project. We grouped all projects or part of the projects into a brochure that we also have available in English. It's called Flanders SmartEnergy region. When you would be interested, I have no problems in sending it you through. And I would really look forward to have a good link with all of you. If you see some possibilities in cooperation with Flemish companies, if you see some possibilities in coming to the Flemish region, don't hesitate to call us. We are there to help you, and I was able to show you one of the multiple projects that we have in the area of smart grids. So thank you.
Thank you, Frederick. Thank you very much. And yes, we hope to be able to meet maybe on a NLIT trade show later this year, if we all manage to organize.
Let's keep fingers crossed.
Exactly. And now I don't see any question for you, so I guess I will give the floor to the next speaker, who is Cédric Brûle. Who will make a presentation about the opportunities within another cluster in Belgium, but French-speaking cluster, TWID. Cédric, are you able to join us? Need to turn on your camera, your microphone. Yes.
Yes. You hear me?
Yes. Very good.
Okay.
Welcome.
Yes.
Just before you start, I need to let you know that I need to rush to another meeting. So I say goodbye. I leave you in good hands with Bastien and Nathalie from Minalogic, and have a good session. Thank you.
Okay. So welcome everybody. So I'm Cédric from TWID, so the energy cluster in Walonia. So in one slide, our groups. I don't see the slides. All right. So I will go through the presentation. So our cluster has 140 players in the renewable energy sector, energy transition. So very quickly, you can discover all these players in one website called rewalonia.be. So TWID is the cluster for, let's say, the French-speaking area, so Brussels and Walonia. So you can discover all the players of the value chain, and we have, I think, 350 players inside our this website, and for each players you can have all the competencies and know-how that they have in the renewable energy sectors. So I think it's a useful tool to find some partners, so don't hesitate to use it, but for sure TWID can be a perfect contact point for you for the matchmaking. In terms of smart grids and smart meters and devices, we have a specific website that we shared with Flux 50, so our counterpart. So we have two websites that are very focused on the smart meters. In the French part of this website is managed by Tweed, is Maconso sous la loupe. And this website, the objective is to have a list of all the devices and smart meters that are using the smart meters and can create some added value to put smart meters on the market. And so we try with this website to show to the public, so it's really B2C tool, that there is an added value to present and to have smart meters in the houses. For sure, we see that it's a needed hardware that we need for energy communities, microgrid, and so on. So I think it's very important to promote it. And sometimes we have difficulties because some people don't want, just because they think the only added value is for the supplier to have a bill, and so there is no win-win situation. And this website is trying to show that there is a win situation for the consumer as well. So it's Maconso sous la loupe. If you want to discover, I think there are 35 players in the database right now. In one slide, energy transition in Walonia, and I think it's both case for Belgium. The challenge is the phasing out of nuclear energy. So I put it because I'm in a French organization, and so for sure it's a common topic, the phasing out of nuclear. It's really concrete in Belgium. In 2025, we will be out of nuclear energy for the electricity part. And so the main challenge is to produce more and more renewables, but still in the same time to produce more and more flexibility in the system. And so we see that we are creating right now some markets for the flexibility in Belgium, and we are quite active in this field. So it's for the reserve, it's for the frequency, and so we see more and more business model that we can create in this field. So very quickly, the smart grids value chain in Walonia. We have done an analysis for the smart grids value chain in our cluster. It was 3 or 4 years ago, and we have discovered that 73 players in Walonia have at least one technology that can be very useful for the value chain in the smart grids. In the same time, we have done a SWOT analysis and job provision and job description needed, because we see that when we evolve in the decentralization of the sector, we need more and more specific job description, and our companies have difficulties to find the good persons to people to do the job. And so it was very interesting to see that more and more data analytics people are needed, and it's quite difficult to find it. So the objective of the value chain analysis was at the same time to discover where we can make some trainings and help companies to find the good people. So what we have done is to very split the value chain in smart grids in different topics. So it's from R&D to conception, studies, transport, installation, for sure the hardware, until the recycling of the system. So you need a great number of companies and know-how, university, R&D centers that can provide some knowledge in it. And at the same time, if you go to the hardware, you see that our study was in French, so you can read it for sure easily. So we see that we need some pilot devices, control system, measuring systems as well, monitoring infrastructure, and we see a lot of technologies and hardware that can be provided within the smart grids, let's say, a new value chain. Just some example of smart grids project that we handle in the cluster, because like Flux 50 are really objective, and like Tenerrdis, it's to gather some companies in specific innovative or investment projects. In the field of smart grids, I took an example here of a project that is in fact a project of Flux 50, but it's a good example of project where we find some partners from Walonia, Flanders, and that are teaming up to provide a solution. Here, it's to provide a solution of flexibility for the houses and to deliver some services, auxiliary services to the grid. And so you need, if you to be successful in it, you need grid operators in the project. You need data. Let's say optimization and flexibility services, reflection and optimization with data analytics. You need some flexibility, and Thermovolt is providing some flexibility within the houses with the thermal boiler, for example. And you need an aggregator, so it's the restore player. And when you bring in all these players, you can have a global solution to the market. It's what we are trying in the different projects. It's to bring different value and offer a single solution to the market. Another project is let's say the hot topic in Belgium right now. It's to see that we are managing it's not really the smart grids, it's more the microgrids, but I think it's very related. So we see more and more projects that are open microgrids. So we try to organize a project like a renewable energy community, for example, here within a business park level, but this renewable energy community and microgrid is open to the grid. So really the objective is to show that if we size correctly the energy community, it can provide some services to the grid in the same time. And so here it's a project with NG and some IT providers and public and grid operator and university. And together they are trying to provide one single solution in a big business park level. For sure, what we are seeing in Walonia, and I think maybe in France, and it could be a discussion, it's the need of flexibility in the system. So because we are losing the nuclear plant, we need some flexibility in the system, and it will be very difficult for in the future. And so we see a lot of business cases that are coming up in the market. For sure, when you have application like batteries, you see that there are very different added value that they can provide. And in fact, you need to stack this value and you can have projects that have two different valorization. For example, we see in Belgium big batteries project of 10 megawatts that are coming on the market. And these projects are related to the self-consumption in a microgrid area, but in the same time, they offer frequency services to the grid. And when you add the two values, you have a business case that is coming up without subsidies. So we see really this type of project that are coming up. For sure, it's an important topic, storage for the smart grids. So I have 2 or 3 examples of storage application within this flexibility services in the cluster. The first one is a large industrial microgrid with an energy storage pilot plant. So the idea here is to test different type of batteries, flow batteries, lithium-ion battery within a microgrid. And so you can optimize it. And for sure, I've heard today some great companies of Tenerrdis and Minalogic that can help for sure this type of project. So we see that this type of optimization are very, very important for the market. Another project is the pumped hydro storage. And we see here the target is very big industries that have more let's say space to put some solar panels and that have some field where you can easily put a small pumped hydro storage. When we see, when I mean small, it's from 1 to 5 megawatt. And with this type of size in this storage, we can offer some flexibility to 1 or 2 or few industries in terms of self-consumption, but as well for the balancing of the system in general. And I think it's my last project, example of project, is Acutherm. It's a project of storage of coal, thermal energy. So here it's the idea, it's to provide with phase change materials and to improve the cold storage systems. So for example, it's to offer to agro-food industry that are using cold storage for meat, for example, or food. We can offer some flexibility to the grid with this phase change materials because they can offer more flexibility. So typically, you are providing more electricity during the day, and the fridge is taking more electricity during that time. And for the night, it's coming up to the fridge or to the grid. And so we see that this type of technology have a great potential. And at the same time, it's a project that is very innovative, and so we help them to get some financing behind this type of project and to prove that the pilots can be successful. So I think it was my last slide. I would be very happy to discuss with some companies if needed, for sure.
Thank you very much, Cedric, for this overview on smart grids on the region of Walonia in Belgium. I don't see any question for now, but you still have the chance to ask Cedric some questions if you have already registered on the platform, B2B platform. In the meanwhile, we will just ask you to complete a survey. We have prepared a small survey. It's pretty easy to use. You just have to, when the survey appears, you will have to answers to the different questions. So I believe you do have it in front of you. Great. So you have different questions on the level of satisfaction, on how useful was for you this or previous webinars, because taking into consideration that was a pack of 6 sessions on smart grids. Very important also, you have a question concerning your expectations. Are your expectation to find a business partner? Are your expectation to find an innovation partner? Maybe you have technological needs. Maybe you are looking for application use cases, partnerships. So you have in front of you the different questions. I will give you 2 or 3 more minutes, and then I will come back with some information before closing this session. So I will stay quiet for now so you can focus on the question and answers. By the way, Cedric, I believe you have a question in the chat. So maybe, Natalie, if you can bring Cedric back to the speaker zone so he can maybe answer directly. So maybe I will share briefly with you some results because you don't see it, but we have the feedback on here. So most of you are satisfied. Half of you have already participated to previous webinars, so that's great. that there is a continuity between the different webinars presented. Half of you acquire new knowledge and half of you already have the information. You discover, almost all of you discover new key players on smart grids. That's great to know. Half of you already have new contacts. 1/3 is looking for collaborative project, 1/3 for business opportunities. I mean, that's compatible, so there's no problem. 1/3 it's other, so maybe next time we can think about what other means. Almost half of you have also we would like to pursue collaboration with. So this is an important point. I mean, one of the framework that will be at your disposal to continue with collaboration schemes will be the Cluster Exchange platform. I will come back briefly with it just after this. And very important, and this is related also to the Cluster Exchange platform, if sanitary conditions improve, most of you would like to have a physical business mission. So yes, let's close the survey, Natalie. Also to answer to some of your expectations and to give some sustainability scheme to what has been done till now, a quick reminder on two things. I will come back to the beginning of the presentation. Just have first thing, you have a platform, as you know, to have meetings with the people that are present today. But also, you will have the opportunity to create links with people that have presented before, and a broader environment and collaboration scheme. So that's why we have the Cluster Exchange. This is a platform for clusters and cluster members. So you will receive the information, but please take into consideration that in this platform, like all other platforms, you do create a profile and then you have a certain request. The requests are partnership requests, and then you will have an algorithm that works on matching the best partner for you. What comes on that? You will be able to organize missions. It can be from 4 days to 1 month to foreign country partners. The good thing also is that beside the partnership collaboration scheme, you will also receive financial support to cover your expenses and to cover your travel. So this is very interesting. We'll send you the information. We'll stay at your full disposal to discuss it furthermore, because of course it is a pretty comprehensive platform. So there's a lot of information to bear in mind. But take into consideration that this is the way to provide sustainability to the first concept we have, that you have support from our side and from the European Commission side, and also that everything, well, not everything, but at least you will receive some funding to promote these exchanges. So this is all from me today. We are really grateful and happy to have hosted you and listened to your different speeches. Again, thank you for your participation and loyalty. You still have the platform for your B2Bs starting in 5 minutes. And then from Tenerrdis side and from Minalogic side, we stay at your full disposal if you have any requests or information. Thank you very much and have a nice day. Thank you.